Hello, this is our narrated version of the Chapter 8 PowerPoint. This chapter is all about air masses. Okay, so what is an air mass? It's basically a giant body of air, perhaps 1,600 kilometers wide, that is going to have basically similar or homogeneous temperature, profile, stability, and moisture content all throughout. So it's a big body of air that has similar characteristics all throughout. And they're going to form over source regions, and we're going to see that the United States is not a source region. These air masses are going to form in other places, but they're going to move into the United States all the time, bringing us different types of weather and creating clashes of air masses that eventually form mid-latitude cyclones. So this is a very simplified drawing, kind of giving us an introduction to the different types of air masses, where they're going to form, and where are they going to move. To be fair, this image would be better served later in this PowerPoint, but that's okay because we will see similar images later in the PowerPoint. And what is going to separate these different air masses? And the answer is they're going to be separated by fronts or frontal boundaries, say warm fronts and cold fronts, for example. So, air masses that form over the high latitudes of the South Atlantic will be cold and humid. High latitudes of the South Atlantic. We're talking South Atlantic, we're talking Southern Hemisphere. High latitudes means getting closer to 90, getting closer to the pole. So South Atlantic is not quite to Antarctica, but these air masses will be cold because they're getting close to the South Pole, and they will be humid because they're forming over water. If an air mass formed over Antarctica itself, it would be cold and dry. Why would it be dry? Because it's forming over a land mass. So we're going to see that maritime air masses, particularly maritime tropical air masses, are going to affect the eastern half to 2/3 of the United States all the time. But just maritime in general is referring to, of course, salt water, ocean water. So maritime air masses are going to acquire their properties of temperature and moisture from extensive and physically uniform areas called source regions, meaning so maritime air masses are going to form over oceans. We're going to see that we're going to have two types of maritime air masses. We will have maritime tropical and we will have maritime polar. We're also going to have continental air masses, and this image here is the Canadian tundra, so this is going to be, higher latitude air mass, so it's going to be relatively cold and it's going to be dry because it forms over a continent. So we're going to have continental polar air masses, and we're also going to have continental tropical air masses. And we will occasionally we will have continental Arctic air masses over the North Pole. Desert air masses. We will briefly discuss the continental tropic air mass a little bit later on in this PowerPoint, but clearly this is a desert environment. This might be, say, Arizona, New Mexico, maybe part of California. And a desert air mass, continental tropical, is going to be hot and dry. Hot because it's tropical, and dry because it's forming over land. Oh, this scene comes from Arizona. It's the Sonoran Desert. It's really very pretty. So we will see later in this presentation that occasionally we get maritime tropical air masses from the Gulf of Mexico or the Pacific Ocean that might move into the desert areas, bringing a what do we call that? Monsoon, bringing the occasional wet monsoon to the desert. And you actually see that happening here. This is a desert image, but what do we see? Well, we see a cumulonimbus thunderhead in the distance. We see part of a rainbow, which means that there are some water droplets in the air. This is an image of lake effect snow. And this goes back to December 2001, late December, where you had a big lake effect snowstorm that dropped about 7 feet of snow onto Buffalo, New York. Okay, so if you look kind of to the left of this image where this man hasn't yet shoveled snow, you see just how high it is piled up on the roof. And why might somebody risk their life climbing the roof to shovel snow? Well, you guessed it, too much snow could cause a roof to cave in. And of course, if a roof was flat, it would be even worse. And we could argue, well, this appears to be a single-story house, and he's shoveling all that snow right just off the roof. So if he should tumble off the roof, hopefully he would fall into one of those snow piles he created and not get hurt. Okay, so another way to describe air mass is this first little paragraph here. A very large body of air that is characterized by uniform relative humidity and uniform temperature all throughout at any given altitude and also across in a horizontal fashion. In this particular example here, you've got well, that's either going to be continental polar, it might actually be continental Arctic. They're going all the way down to Tampico, Mexico. That's going to be a continental polar air mass moving way far south, and that's only going to happen in the winter time. Okay, this is kind of important. So why does the U.S. not make its own air masses? Why is the U.S. not a source region for air masses? Well, we're going to get to that. But first, let's discuss what 2 criteria must be met for an area to be classified as an air mass source region. Okay, so a source region must be extensive and physically uniform region. So it could be an ocean, it could be the Pacific Ocean, it could be the Atlantic Ocean, or it could be a continent. Now, we're not getting air masses forming in the United States, but air masses can form in Canada. So that's part of the North American continent. It's relatively physically uniform. What other criteria must be met? You must have general stagnation of atmospheric circulation. So that last snippet there is why the United States is not going to form its own air masses. We have way too much circulation and mixing. So air masses do not form here in the United States, even though they do form in Canada and places all around us, but the air masses will move into the United States and bring us various types of weather. Okay, so we're going to create 5 air masses. You might look at this and think that we're going to make 6, but we're only going to make 5. So it's going to depend on the latitude, meaning temperature. And for latitude, you're going to have 3 different choices. You're going to have tropic, like lower latitudes. You're going to have polar, higher latitudes, and then you're going to have Arctic. Latitudes that are so high they're within the Arctic Circle. Okay, so 3 different groups for latitude. But air masses are also going to depend on the surface area. And we have 2 types of surface areas on this planet. We have marine and we have continental. Okay, so we're going to make combinations out of these, polar, Arctic, and tropic, and then marine, continental. And again, bringing them together, you might think we're going to make 6 types of air masses, but we're only going to make 5. Why only 5? We will get to that. Back, I should switch these slides around. Now that we've discussed these, let's go back and look at these maps again. So again, this is showing you, both for summer and for winter, where these different air masses are going to form, and then the arrows show where they tend to move to. So you see again that we don't really have any air masses forming in the United States. They're going to form in other places and move into the United States. And even that continental tropical is really going to form more so in Mexico and move into the United States. Oh, we forgot to answer this question. Which air masses most influence the weather here, say, not just in Pembroke, but in the eastern United States? There are two that are going to do that. For the most part, it's going to be maritime tropical and continental polar. Okay, so this is basically just restating everything we just went over, so I'm not going to spend time on this. There might be too much information in these PowerPoints because we're using the PowerPoints that I used for the online class, so there's additional information. You can always pause this recording and take a look at these, but we'll go ahead and skip this because we've basically talked about this already. Okay, so regions that have a lot of circulation, in general cyclonic circulation, which just means low pressure and rotating counterclockwise, these areas are not conducive to forming air masses because the atmosphere in these regions is not stagnant, and the United States is one of these regions. We have these mid-latitude cyclones forming all the time and traveling from west to east across the United States, and we just have way too much air mixing, therefore we do not produce our own air masses. So this slide here is a pretty good one. I think this is from your textbook, and I do recommend pausing this recording and reading through this. It has a little more information than we have shown before. It shows you very well the source region, where they tend to form. It lets you know the temperature and moisture characteristics in that region. It goes into more detail on the stability. What's most interesting is over there on the right, associated weather. So we might take a look at some of these. Okay, continental polar. Cold waves in the winter, modified to CPK in winter over the Great Lakes, bringing lake effect snow. We'll talk about modification of air masses soon. Maritime polar. Low clouds and showers in winter. Heavy orographic precipitation on windward side of western mountains in winter. Low stratus and fog along coast in summer, modified to continental polar inland. So the maritime polar is affecting the Pacific Northwest. You do occasionally have maritime polar affecting the northeast coast as well, bringing the occasional nor'easter in winter, occasional periods of clear, cool weather in the summer. Continental tropical, only affecting northern interior Mexico and southwest US, and really only appearing in the summer. Okay, maritime tropical is very important. So the maritime tropical that forms in the Gulf of Mexico, Caribbean Sea, and Western Atlantic is going to affect the eastern two-thirds of the United States pretty often. In winter, usually becomes MTW, modified, moving northward and bringing occasional widespread precipitation or advection fog. In summer, hot and humid conditions, frequent cumulus development, and showers or thunderstorms. Now there is maritime tropical that forms in the eastern subtropical Pacific, and it's going to affect southwestern United States. In winter, it brings fog, drizzle, and occasional moderate precipitation to northwestern Mexico and the southwestern United States. They do occasionally get rain in the southwestern United States. In summer, it occasionally reaches the western U.S. and is a source of moisture for infrequent convectional thunderstorms. Okay, so a nice question here. This question is not in your exam, but it's pretty interesting. We will discuss it. So why is there no maritime Arctic? So you might think that up at the North Pole in the Arctic Circle that there would be a maritime Arctic because it's cold and it's seawater. Actually, we've really already answered this, but that's not going to happen because, well, you have ice, floating sea ice, and the air is so very cold that it's not going to hold much moisture. So basically, what would otherwise be classified as maritime Arctic, we're just going to go ahead and call it continental Arctic, because it's as cold and dry as you might find, say, over Antarctica. And don't forget that the poles are frozen deserts. We're going to talk about that, or we should have talked about that in Chapter 7. Okay, so just some additional information here. Maritime polar air masses form over the oceans at high latitudes, North Atlantic or North Pacific. So we can say that maritime polar air is warmer than continental polar air, even though they're both polar. Why is that? Because remember that water holds on to warmth much better than land. So the MP air is warmer than CP and warmer than continental Arctic air masses in winter. Maritime polar air masses from the North Pacific influence North American weather, more so than the ones that you get in the Northeast. But even so, the maritime polar air masses that affect the Pacific Northwest, they're only affecting the Pacific Northwest. That's why you never hear them spoken about much here in North Carolina. You do occasionally get nor'easters, which are wintertime storms, almost like a wintertime tropical storm, a low pressure system that will affect New England. But that's only occasionally. Okay, so that first bullet there is an exam question. I'm going to be printing study guides. Actually, I've already got them printed. I'm going to bring them this week and hand them out. So maritime polar air that forms over the Pacific Ocean actually usually begins over in Siberia, so over top of the Eurasian continent, and it's going to begin as continental polar air. So it starts in Siberia, cold, dry air, but it's moving east. And as it moves east and goes all the way across the pretty vast Pacific Ocean, it's going to pick up lots of moisture. So when this air mass arrives in the Pacific Northwest, it's maritime polar at that point. And of course, it's going to bring lots of moisture, clouds, and rain to the Pacific Northwest, as we might expect to get, say, in Seattle. Okay, so again, exam question. Maritime polar air. Oh, different one. North Atlantic. Okay, so maritime polar air from the North Atlantic also probably began originally as continental polar. So say this could form, for example, over Greenland. But again, it's pretty rare that we get this maritime polar air from the North Atlantic moving into the Northeast. When it does happen, it's actually pretty neat. So in the late 90s, I lived in Virginia Beach for 3 years. I was working on a master's degree in economics at Old Dominion University. I ended up not finishing that degree and switching and doing geology instead. But one winter, we had these back-to-back nor'easters. They called them the twin nor'easters, and they moved so far south that they affected the east coast of Virginia. And I got to tell you, it was like a tropical storm in the wintertime. There was all kinds of beach erosion, and we just had rain, but of course further north they had freezing rain. And I will never forget those nor'easters. There was so much beach erosion in the winter. So maritime tropical air masses, for the most part, the ones that are going to affect us in the eastern 2/3 of the United States, they are going to originate over the Gulf of Mexico, the Caribbean Sea, or the Western Atlantic. And these maritime tropical air masses are going to be warm to hot, and they're going to be very moist, and they're going to be very unstable, and they are capable of significant precipitation. So these maritime tropical air masses that form, say, from the Atlantic or the Gulf or Caribbean Sea, they are basically affecting the weather east of the Rocky Mountains. This is why I keep saying the eastern 2/3 of the United States are affected pretty often by these maritime tropical air masses, particularly in the warmer months. Okay, so in the summer, these maritime tropical air masses are going to affect a much wider area of North America, just meaning that they'll move further north into the more northern states. And they still move into the United States in the winter. They're not able to move quite as far north in the winter time. Now, in the summer, as you have this maritime tropical air mass moving over the United States and moving landward, it's going to become changed or modified. It's going to get warmed from below due to daytime heating. So we could say it gets modified to MTK. We're going to talk about modification on an upcoming slide. Anyway, during the daytime and the hot months when these maritime tropical air masses move into the United States, they are very commonly forming afternoon pop-up thunderstorms. So during the winter, these maritime tropical air masses will affect the Gulf states a good bit and the East Coast. But as far as like moving into the central states, it's only occasionally going to happen because there's going to be a battle between this maritime tropical air mass and the continental polar air mass coming down from Canada. So that last bullet there is also discussing air mass modification, which we'll get into more in an upcoming slide. But when the lower portions of air are chilled from below, then they become a little more stable. Then the maritime tropical air is changed to MTW, which means it's cooled from below. And what this can do is bring the possibility of widespread advection fog and perhaps increased precipitation. Of course, this is in the winter. I know there's a lot of information on this slide. Sorry about that. Okay, so North Pacific maritime air. In the summer, these air masses have less of an impact on North American weather. And they're using North Pacific just to denote the North Basin of the Pacific, not saying you're at a high latitude in the Pacific. So just imagine the North Basin of the Pacific, as in, north of the equator in the summertime. So you occasionally get these maritime air masses from the Pacific affecting the West Coast. So if this air mass moves northward, then it can cool, and this can allow for condensation, and you might get fog, drizzle, or moderate precipitation, say maybe on the Northwest Pacific coast. How about the Southwest Pacific coast? So these maritime tropical air masses from the subtropical North Pacific, that's the best way to describe, it's the North Pacific Basin, and it's north of the equator. From the subtropical North Pacific can cause this phenomenon that they occasionally get in Southern California, referred to as the Pineapple Express. And it can bring extraordinary rains to Southern California and other West Coast locations, places that are not used to getting a tremendous amount of rain. Boy, they could use some rain right now out in California and other West Coast areas, couldn't they? All those fires going on. This is fall of 2020, by the way. So here's a nice, how do they take this image? This has got to be, this is from a satellite in orbit. This is a satellite image here of the Pineapple Express. So it's basically this river of clouds and moisture that's moving in from what we're going to refer to as the subtropical North Pacific, bringing moisture into Southern California. Okay, so now let's talk about continental tropic air masses. So these are produced in the interior of Mexico. They're only around in the summer, and they will move north just a little bit into the southwestern United States. So continental tropical, hot and dry. Hot because it's tropical, dry because it's continental. So you'll have these cloudless blue sky days with almost complete lack of rainfall, causing drought and just, making sure that desert stays a desert, I guess. Okay, question here that kind of goes back to table 8.1, which is back on slide 18. And this is something that we didn't talk about together, but you can go back and read through that table on your own, and I recommend that you do. So why would maritime polar air masses be stable in summer and unstable in winter? And again, we're talking maritime polar here, not maritime tropical. Maritime polar air masses, like say affecting the Pacific Northwest, they're stable in summer but unstable in winter. In summertime, the maritime polar air is cooler than the air over the continent. This goes back to that differential heating between land versus water. So even though it's maritime polar air mass, it's still maritime and it's therefore cooler than the hot continent in the summertime. So that air mass is stable and it will tend to sink. Remember, if the air mass sinks, it's stable. If it tends to rise, then it's unstable or instability. Okay, so in wintertime, say in the Pacific Northwest, the continent is pretty darn cold. And that maritime polar air mass moving in is cool, but it's not as cold as what's over the continent. So it will be warmer than the surrounding air over the continent, and this will be a lifting mechanism and can bring precipitation. Okay, during winter, polar air masses are cold. Yes, we might expect that. Which should be colder during winter time? A maritime polar air mass or a continental polar air mass? Continental polar air masses, especially in wintertime, are going to be colder than maritime polar air masses in general, because the continental source region for a continental polar air mass is going to be colder than the ocean source region for that maritime polar air mass during the winter. Okay, exam question here for sure. Pretty easy. Which two air masses are the most important affecting the weather of the eastern United States, say east of the Rocky Mountains? And there are two of them. The maritime tropical coming from Atlantic, Gulf, or Caribbean, and the continental polar coming down from Canada. Most important to the weather east of the Rockies. Continental polar air masses dominate in winter, often bringing cold waves. Moisture from maritime tropical air mass is the primary source of much, if not most, of the precipitation received in the eastern two-thirds of the United States. And that's true all throughout the year. Okay, so we're finally to air mass modification. Maybe this PowerPoint will only be 45 minutes or less. I'm kind of hoping. Okay, so air masses are going to take on their characteristics where they form in their source region. But the air mass then migrates and it comes into the United States, for example, and it can be changed or modified by the surfaces over which it moves. So the air mass could be warmed or it could be cooled. And this is always coming from below, from the surface, and this will, of course, affect its stability. So the letters that we add might seem counterintuitive. Okay, so if the air mass is warmed from below, we add a K. And you might ask, why are you adding a K instead of a W? We're adding a K because it's cooled from below. If an air mass is cooled, okay, let me say that again. I may have completely messed that up, and I'm not going to restart this. We're 28 minutes in. If an air mass is warmed from below, yes, I did mess that up. If the air mass is warmed from below, we're going to add a K, saying that that air mass is colder than what it passed over. So if it's warm from below, you're going to add a K. If it's cooled from below, you're going to add a W, not a K. Why? Because if it's cooled from below, then it's warmer than what it passed over. Okay, so an example, continental polar, CP, becomes CPK. The K means it's warmed from below. Okay, another example, maritime tropical, MT is modified to MTW, means that it was cooled from below. All right, so this slide here, the first part of it is basically what we were just saying. If you add K, that means that the air mass was warm from below, meaning that it was colder than the surface over which it passed. If you see that the lowercase letter w has been added, it means that that surface was cooled from below, meaning that the air mass is warmer than the surface below it. So now let's look at the bottom part of the screen and discuss what is that going to do to stability, and how might that affect the weather. Okay, so a K air mass is warm from below, and thus it is made less stable. Okay, remember, if it's warmed, then it's more likely to rise, so it's less stable. Therefore, such an air mass might have cumulus clouds, cumulus congestus, could bring showers, could bring or build cumulonimbus clouds and thunderstorms. So precipitation is expected. All right, on the other hand, if an air mass is chilled from below, we're going to add a W to it, meaning it's warmer than what it passed over, so it's chilled from below. If the air mass is chilled from below, that's going to make it more stable. Anything that cools that air mass makes it more stable because it's less likely to lift, okay? So if a W air mass has clouds, they will be stratiform clouds, like the stratus clouds. And you may just have a cloudy day with no precipitation, or if you have any precipitation, it's going to be very light. And advection fog and poor visibility are often associated with the air mass that has been cooled from below, modified with. Okay, properties of air masses. So I'm going to want you to know how lake effect snow forms. All right, so lake effect snow, we're talking the Great Lakes, and lake effect snow is usually on the eastern side or leeward side of the Great Lakes. So it's the result of cold air mass moving over warmer water. So this happens in autumn and early winter when the continent in the northern United States and lower Canada, the continent's pretty cold, and the Great Lakes are actually a little warmer. So you start with this continental polar air mass that comes down from Canada, swoops into the United States, heads east, and then it moves over the Great Lakes. So the Great Lakes are a little warmer than the continent. So that air mass is going to warm from below. Warm because that water's a little warmer. It's also going to pick up moisture. So the continental polar air mass then is going to become CPK. We'll probably see that on the next slide. So it's going to warm and it's going to gather moisture, and then it gets to the leeward side of the lake and it hits that cold continent and it's going to cool, and you're going to have lots of condensation and you're going to drop tons of snow. All right, so this is a nice, this is what we just said on the last slide, and this is a really good diagram to show that. Continental polar air coming in from Canada, moving east, heading over the Great Lakes. Great Lakes are not necessarily warm. You wouldn't go swimming in it at that time, but it's warm enough that you're going to warm that air mass. You're going to pick up moisture. CP becomes CPK, and then you're going to get snow. And then in the bottom right, you see a satellite image there showing clouds bringing snow and precipitation to places like Buffalo, New York. And here we zoom in on that. So this is December 27th back in 2001. Thick bands of clouds extending from the eastern tip of Lake Erie to east of Buffalo. Anyway, you definitely get more snowfall on the leeward side of these lakes than you do in some other places. And that is called lake effect snow. So Buffalo is not just known for buffalo wings, it's also known for lake effect snow. Here we go. I was hoping the slide was coming soon. So what we're looking at here are snow belts of the Great Lakes region. First I'm going to point out the Appalachian Mountains. They're dipping down into West Virginia. They are not part of the lake effect snow, but you have increased snowfall there. Why? Mountains, orographic lifting mechanism, and you're going to get snow in those mountains. Okay, now back up to the lakes, and you see there that and it's not evenly distributed. East of Lake Erie, east of Lake Ontario, and east of that separate part of Lake Huron there tend to have the most. Oh, and around Lake Superior. Yeah. Anyway, but you still get lake effect snow east of Lake Huron and Lake Michigan as well. But you don't just have uniform snow everywhere here in the Northeast. Depends on where you are. If you really like snow and you get your dream job in Buffalo, New York, you should go there. So these are just showing Thunder Bay, Ontario and Marquette, Michigan. Is this a particular year? Maybe these are just averages of the amount of snow that you're going to get in inches and centimeters at certain times of year. And this is, what are we going to call these? You can't call them isobars, and you can't call them isotherms. In geology, we would say these are isopochs. Basically, each line here is connecting an area where you had an equal amount of snowfall in inches. And notice that around Chardon, 60 inches of snow. That's incredible. Look at that picture there of the people on the roof there getting all that snow off the roof. Dangerous work. Okay, so now we're looking down at the Gulf Coast and the Gulf of Mexico. So this is December 2007. Ooh, here we've had the jet stream dip far south, bringing continental polar air all the way from Canada down into the Gulf of Mexico area. And then this CP air mass moved over the Gulf of Mexico. It's going to get warm from below, so it'll become CPK. And do we have any evidence that the warming has allowed for condensation? Sure we do. Look at all that cloud cover. Okay, I think we're just gonna kind of skip this slide here. We're not gonna worry so much about vertical movements induced by pressure systems or topography acting to modify an air mass. They might just affect the stability of the air mass, but vertical movements are not gonna significantly warm or chill an air mass from below. Okay, so Siberian Express, this may possibly be an extra credit question on the second exam. This goes back to 1989. My goodness, look at that cold front. Okay, so that cold front dipping way down into the Gulf of Mexico. This is evidence of the jet stream dipping far south. So the Siberian Express, this occasionally happens. Okay, the arrival of an extremely cold air mass of Arctic origin. Meaning continental Arctic. Okay, so normally Canada is affected by continental Arctic air masses in the winter, and not very often the United States. We get the continental polar air masses dipping down into the United States all the time, but we can occasionally get the very cold, very dry continental Arctic air masses moving down into the United States. And when this happens, they might refer to it as the Siberian Express. And boy, you know it when it happens, because things will be just they'll just feel really bitter cold for our area, and we will of course whine about it because we're not used to that. Okay, so I believe this is looking at the same thing here. This is a cold wave and Siberian Express outbreak happening back in 1989. We're asking, what is the wind direction in North Carolina? Well, looking at those wind barbs there, where it says 12, which begs the question, is that the temperature at that time? I believe it probably is, and our winds are coming from the northwest, so we would call that a northwest wind direction. Okay, we're going to skip this. Okay, interesting question here. I can't remember if this is an exam question or not. So, you know, we've discussed that the two air masses that are most likely affecting The eastern two-thirds of the United States, or east of the Rockies, are continental, polar, and maritime tropical, and those come into the United States all the time. But a specific question here, up there at the top left, why do continental, polar, and sometimes continental Arctic air masses often sweep so far south into the United States? Because there are no major topographic barriers to the movement, say from north to south, between their source region and the Gulf of Mexico. Do we have topographic barriers? We do. We have the Rocky Mountains and the Appalachian Mountains. Of course, the Appalachian Mountains aren't nearly as tall. So they're going to affect what happens to, say, the westerlies, the winds blowing from west to east. But as far as north-south migration of continental, polar, and continental Arctic air masses, well, there's just no barriers to that. And they don't mention it here, but this also allows for the maritime tropical air masses from the Gulf of Mexico to move pretty far north into the United States, especially in the summer. Okay, so why do maritime polar air masses from the North Atlantic rarely affect the eastern U.S.? Okay, so they do occasionally affect the eastern U.S. and bring us these things called nor'easters, but they're pretty rare. And why is that? Because we are in a band of winds known as the westerlies, meaning that the winds are blowing from west to east. So it's kind of rare for these maritime polar air masses that form over the North Atlantic to actually move into New England. But it does occasionally happen, especially if you have a low pressure cell moving up the East Coast. If low pressure is moving up the East Coast, then that low pressure can draw in that maritime polar air and bring us a nor'easter. This map is impossible to read, but anyway, it's supposed to be showing a nor'easter moving up the East Coast. Okay, question. Which air mass is most often going to affect the West Coast? Maritime polar air mass, and particularly the Pacific Northwest. But we could say the West Coast in general is usually being affected by the maritime polar air mass. Not so much from continental polar. The area east of the Rocky Mountains is pretty often going to get that continental polar air mass from Canada. Okay, and this slide probably should be moved. We talked about this many slides ago. So in the wintertime, you often get maritime polar air masses hitting the West Coast, and in particularly the Pacific Northwest. And I think this is an exam question. Yes, it definitely is. What do these maritime polar air masses begin as? And the answer is they begin as continental polar air, forming over Siberia, the northern Eurasian continent. And then as it moves east, it's going to head out over the Pacific, and it's going to modify to the point that it's going to completely change into a different air mass. It's then going to be maritime polar. So it's still cold, maybe not as cold. It's been somewhat warmed. But we've gone from continental air mass to maritime air mass. Why? Because it's traveled across this vast Pacific Ocean and gathered a lot of moisture. All right, so what are we looking at here? Okay, question. What air mass and source region provide the greatest amount of moisture to the eastern and central United States? Maritime tropical air. And it's coming primarily from the Gulf of Mexico, but it's also coming from the Caribbean and Atlantic, but we get more of it from the Gulf of Mexico into the central United States. And then you see here in the map, the different color shades are showing you, average annual precipitation in inches and centimeters for these different areas. So the Gulf Coast states get a lot of rain from these maritime tropical air masses coming from the Gulf of Mexico. Okay, so maritime tropical air bringing summer rain. So from the Gulf of Mexico, in the summer, that maritime tropical air mass can move pretty far north. And again, this can bring afternoon thunderstorms pretty often. Okay, so North Pacific maritime tropical air masses from the Pacific source. Okay, we kind of mentioned this before. This slide is discussing the Pineapple Express again. We've covered that already. You know what's new though? That image there on the bottom right shows some severe flooding going on in Southern California, something they're not necessarily used to all the time, and that has been brought to them from the Pineapple Express. Subtropical Northern Pacific Ocean maritime tropical air mass. Aha, we're finally going to talk about Arizona's monsoon season. So Arizona has a monsoon season, just like the continent of India and Southeast Asia have a monsoon season. And the monsoon isn't just the wet monsoon, although that's what everybody thinks. There's a wet monsoon and a dry monsoon. And you see here that, yes, Arizona is, well, it's dry. It's basically a desert. I mean, look at the picture. But it does have some rainfall in the summer months, July, August, September, October. Really, really dry, I guess, in the spring to early summer. But it gets decent at, well, decent, how much rain? It looks like a lot because the blue bars there look tall. But when you then look over on the right, what do they mean by a lot of rain in July and August? Wow, 2.5 inches. Okay. Anyway, that is their summer wet monsoon season. Okay. Oh, yeah, we're going to go over these together. For each of the following, indicate which air mass is most likely involved and from what source region. A, summer drought in the southern Great Plains. Southern Great Plains summer drought, that's probably continental tropical. B, wintertime advection fog in the Midwest is probably going to be maritime tropical from the Gulf of Mexico, moving over the cold continent, getting chilled from below and making advection fog. C, heavy winter precipitation in the western mountains. So we're talking Cascades and Rockies. That's probably going to be maritime polar. D, summer convection showers in the Midwest and East U.S. That's going to be maritime tropical from Atlantic, Caribbean, or Gulf. And then a nor'easter is going to be maritime polar from the North Pacific. Did we answer everything? Okay. And then here we are. We're going to check our answers. Oh, and they have added in the air mass modification. Awesome. Okay, so again, these same diagrams will be on your exam, and the words are going to be blotted out, and you're going to have the bubbles there, and I'm going to ask you to fill in what kind of air masses are they. And looking at that map, you should be able to do it. You know, have an idea of where they form, where they move to. Honestly, I think this is one of the easiest chapters in the whole textbook. It's also pretty interesting and cool. And in the UK, you know, they have their own names for things. The bathroom is the loo or the water closet. Your roommate is called your flatmate, or rather your apartment is called your flat. And they have different names as well for their air masses. Oh, and geysers, like at Yellowstone, are called geysers over there in the UK. This might be our last slide. If you want to pause on this and take a look at what happens in the UK, you can do that.